So this was something I'd initially planned to do. Well, I guess I'm not showing my camera, so let's just say off microphone. Or just doing it without uploading it, but, I want that to be lowercase I. General conversation skills and soft skills in general are probably one of, if not my weakest area, so I'm going to be trying to do this while explaining it. So, anyways, here are a list of different things I'm going to try to implement as reference code. The stuff with a question mark is stuff that I probably will not get around to today because it's not that important. Like, I can do this stuff and like this I can do reasonably quickly without needing reference code. This stuff appears irregularly. This stuff doesn't really appear at my level. I added the poor man's ordered multiset because, if you look here, this is like, I even call this dumb word set, multiset. This implementation is bugged, so I'm going to try to hack together a working implementation of ordered multiset using ordered set. I might not get around to that today, so I'll add a question mark to that as well, but this other stuff I definitely want to get around to today. And this is just a test file, so, yep, I don't know what's there. Nothing of importance. And yep, so I guess first of all, let's do a basic primality test, an O squared of n primality test. So that'll be bool is prime. If n is less than 2, return false. Then we want to iterate and if then this is composite, and if it goes all the way to the end, it is prime. And then I make a lot of silly mistakes while writing code like this, so I will write a small testing function. So I'll probably test a lot of stuff here, so I'll actually declare this, just excuse me. I accidentally closed the recording, I just meant to pause, I guess I can just stitch it together. But I'll just do for I equals 0, dot 2, just say 100. I'll make that like this. If is prime count by, I'll make this turn line, so what does this give me? This should return a list of primes up to 100. It doesn't work, so what did I do wrong here? If, yeah, this should be equals 0. Yep, looks right to me. So I'll just mark this as, what's a nice color? Probably something green. Yep. Linear sieve. For this, I'll probably just end up copying my solution from other problems. So, problem I'm pretty sure is this one that I did all this massive stuff on. Of course I do want to, what's it called, reference all this, so. And for the sake of my sanity, I'll make this all primes, and I want to do it like that. I'll probably just do max n. Max pre-computed is too long. I'll just say max values to pre-compute values from this to this exclusive. Oh, that should be fine. And then I'll do it like this. I think for a name that's fine. This is something kind of internal, so do I want to differentiate it? I'll say no, I think that's fine. And of course we'll do max in. And this will make sure it doesn't actually use that, so it uses n, max n instead. We don't want all this to be long for the sake for right now. That looks fine to me. Yep, that'll be internal usage, so I can probably mark like internally use stuff with this. In that case, I will in fact do this. Yep. So what I'll do actually is define sieve. I think macros will work with what's before it as well. And then if I think that's the notation for macros. I don't actually know, so I'll just look it up. Macro if notation C++. If and if directives. Yep. But it's lowercase. I'll probably, yeah, I will pre-compute this stuff always when I'm including this, so we'll just do that at the top. Here, define sieve, and I mean it won't hurt to do it here, so as well. What I'm thinking is we should really end up using this stuff for that as well. And I'll put this after, so I wonder if Yeah, it does note that, so I guess Scout is smart. Does all this compile? It should compile, right? This is like an illegal type of thing. It should be plus max n func. Yep. Oh, that should be func1. Yeah, func1 is a really strange name, so that's why I'm doing all this. I mean, I'm just doing this all by hand. I probably should have found and replaced it. Find and replace, what's the right word for that? But, this one's like that as well. Does this work? If save. Maybe it's if def. Just if def. Oh, and here it should be if def. We want to see a type as well. N wasn't declared, of course, that should be max N. Just brute forcing through all the errors until it stops working. Yep, that should obviously be referencing an array. Yep, works. And this should be near instantaneous. Yep. And that does return all the... It doesn't actually. Do it afterwards. Now, yeah, this is probably slightly inefficient, but I would say let the compiler worry about it, but that's probably not actually that accurate. The compiler doesn't optimize as many things as one would like. So Least prime advisor. What should I call it? Least. I don't think that's overly cumbersome. And then this is. Yeah, it is overly cumbersome, so. Yeah, I'll do it the smart way for now. Where's find? I didn't mean to do it like overall, but I don't think it'll matter. I mean, there's nothing else named FP, so does this compile? Probably not, but yeah, doesn't compile. Save. Where did I put? Oh, I didn't even save this. Yep. And least prime power divisor. I'll include comments for what all these are. So this is so. Yeah, I'm using this twice now. I'll define it beforehand. I could even just like put this as part of this, but I don't think I will. But what I will do is bring this all to the top. It's like a kind of interface. And for this, I do in fact want a binary power function, so... binary power. It'll be worrying that I might accidentally accidentally define something twice. So what I can do is just Should I use namespace? Probably not. Oh, that would be painful. Oh, actually, GCC allows me to do nested functions, right? We'll never have to worry about silly clang stuff, so you can just do it like that. Or I could just make binary power part of my permanent template. That's probably the easiest route. Oh, why am I modifying this? I modified the wrong section. Oh, did I modify all this? No. Let's get rid of that. So let me. Yep, this will be part of our permanent template. And I will condense it, of course. That compiles right. Should. So, what I'll make this do now, instead of all that, is just a few thousand. It'll count. Oh yeah, and if it's actually prime, then I need to what I can just do is if LPPDI and what I'll also do is oh no, I don't need to worry about that, and I'll just make it I'll make it print out both of them. Yeah, looks like it works to me. What does it put for it? 9 times 8 is 72. So that should give us 8. 4 times 27 is 108. And that gives us 4, yep. Then we'll do prime factorization. And we want a temp variable too. Compile yea or nay, probably nay, and then I can fix it. But it actually compiles. So what we'll do is now I'll just do a loop. I'll make this fancy just because prime fact. There's a way of like doing this like as a pair, but can't be bothered learning that. Nah, just here. gone wrong. Probably somewhere up here. Yeah, but that should be that. Why does it care about 0, 1? That might be a little bit of a problem. That should fix it. I think 647 is a cool example. 637. Yeah, my other one is 91. Sorry, 639. I want 91 times 13. That's too complicated. Oh, where's the calculator? 1183. I'll make this go up to 2K. Yep, works out. So, which ones of these did we did? We did all of these, so I'll mark this as green. And, yep. What I'll do is I'll create a new one for the template. And we don't want music. Feels like this is a different window, like, what's it called, File Explorer than the one of my other user, even though I'm using the same desktop environment and everything. I guess it's probably just something weird. So I'll create a file called sieve.cpp. And I'll copy all of this over. And I always want to have max n, so I'll move this up actually. Put some space in between. And make sure this compiles. Probably condense this later, but Don't want that. Don't need to do that now. How long does it take to compile? I don't think it should take much longer. Just one file. Nearly a second longer, strange, but I guess it's worth the pain. Might be other reasons why too, probably because this is open. Modular arithmetic. We can just copy the same thing from that website. I really hate this acronym, by the way, for obvious reasons. Copy the most commonly used mod. Oh, that's not the most commonly used mod. Is this the most commonly? No, it's not. How about this? Still no. That's a custom mod. Well, oh yeah, that's blocked. Oh. Yep. That's what we want. Could probably make this a bit more balanced if I put it like that. Will that replace, I don't think that's safe actually. Oh, there we go. I actually have to find it beforehand, that's annoying. Put all this stuff afterwards. There, is that not, is that, no longer misleading? Should probably, like, modify this CCPC thing to fix that, but anyways, let's just see if this works. Yeah, I probably want this to deal with negative numbers as well, so... what I can do is... this should work because, like, the order of the group of units in a field is everything but that. And then it might be expensive, so... let's just see if that works. Wrong way around. Let's try getting rid of this. It changed, but still the wrong answer. Maybe this calculator's wrong. Doesn't even show what does it say here? Yep, that's right. So where did I go wrong here? Yep, that works. And then the inverse. Will just be that to the power of -1. Do that down here. And here I'll do define. So we want to see if this works. So what I'll do is that. No, that calculator is worked. Yep, works fine for me. I'll probably test this like on a proper solution later. So we have that. We want to do pre-computed inverses as well, so it wants me to compile stuff without anything in between the if statements, right? Yep. This will just be pre-compute. Is that a word? I think it is. Pre-compute, yep. Yep. And then that should work. Oh, just to be safe, I'll just do this too. We've done pre-computed inverses, and we want to do division now. Test this works, we'll do yep, that works out. So, works all this is green. We're going to do pre-computed factorials next. So, This will be just iterating. Yep. You want an NCR function as well. N choices. And we'll just use the formula for that, so... what's the formula again? It's... n factorial over r factorial n minus r factorial. You know what, I'll add a function for safely getting the mod of something, mod. That can be part of my template, actually. And just to see how that works, I'll just do count. So it should return 14, 5. Yeah, 14, 5, and 10. Yep, I think that works. And we'll find NCR now. I'll do add, subtract, and multiply first. Yeah, I don't think that's necessary now. Yeah, I'll get rid of that space. I shouldn't need to do mod here again, and mod is expensive, so I won't. Because I did like for inv mod. Yeah, because B. Actually, no, it might. No, it will be that because it's like mods it there. Oh, but just to be safe. I have no way of knowing. There's like no. But when I do that here, that calculates the inv mod of b. But it'll use this one. Oh, what am I wearing? Let's just wrap this in mod and call it a day. Yeah, it does return the same value, so we have that. And just make sure that this works. That's 5,040 divided by 6 times 24. Yep. So I've done the main things I want to do. So we have a new modified template to work with. Copy all of this over. Copy my new main function. Verify that this compiles. It's good to go. This is the screen recording one, so I'll leave it there anyways. What else that I want to do? Yeah, I'll copy the mod stuff over to a thing called mod.cpp. Yep, and then I have these two reference files. I guess I won't bother with the rest of the stuff today. Oh, bye.